Hello, everyone. Good morning, good afternoon, and good evening to one and all. Dear authors and invited guests, welcome to Technical Session 13E. Myself, Deepika Jain, and the session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, ICICT 2025, London, United Kingdom. The 10th edition of the conference has been organized in a hybrid mode. The physical event was held in London, and the virtual event is being held through Zoom platform, that is from 19th to 21st February 2025. I hope you will enjoy the knowledgeable session throughout the day. In this session, we have 6 presentations. Each presenter will be getting 12 minutes for their presentation and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. If you have any query or update, you can directly write to me in the chat box. I would like to you all to introduce to our session chair, Professor Katerina. I welcome you, ma'am.
Thank you. Good morning.
Works in the Department of Communication and Art in New Media at the University of Aveiro, Portugal, specializing in young people's relationship with digital media, information consumption, and political participation. With a keen interest in media studies and digital communication, she examines the evolving dynamics of political interaction in the digital age. I welcome you, ma'am. We also have another chair with us, Dr. Ruchi Sharma. She's currently working as a professor in Department of Artificial Intelligence and Data Science at JECRC College, Jaipur, India. She is a member of the Asia Society of Researchers, IETE. She is proficient in MATLAB, Virtual Lab, Model Sim, CAT tool, etc. She has presented and published papers in various national and international conferences. Yes, ma'am, I welcome you both here. To begin with our first presenter. Okay, we have it here. We have a first presenter with us who would be presenting a paper on a comprehensive review and comparative analysis of photogrammetry software tools. Yes, sir. Omar Hamid, are you here?
Thank you. So, good morning, everyone, or good evening, depending on your time zone. Today, I'm honored and pleased to present our paper titled A Comprehensive Review and a Comparative Analysis of Photogrammetry Software Tools. So, today I'll take you through an introduction about what photogrammetry is to begin with, the current LR, our research objectives, the methodology we followed, and then discuss our results and future work, ending with some Q&A. Starting with a bit of introduction, what photogrammetry is to start with. One way to define it is the science of extracting reliable measurement and quantitative data of physical objects from images. In general talking, we can do it nowadays from different input, but in general we talk about images. We extract measurements, accurate measurements from them. And you can just imagine how these tools can be used. They're currently used in many applications, such as mapping and surveying, architecture, currently in education, and previously and until now in game development and 3D modeling. So why are we developing these tools? Software tools. There are many advantages of those tools. As I mentioned, the wide range of application is one major advantage. They're being used in many fields across both academia and the industry. Secondly, they're very cost effective compared to traditional 3D scanning. Today, with a single telephone, I can start taking pictures and build 3D models purely based on photogrammetry without needing for expensive equipments and so on. And lastly, they're very easy to use, they're very easy to access. You don't need technical experience. With a bit of training and knowing about the topic, you can start creating 3D models or extracting any measurement you want out of pure images. So both academia and industry are building, developing, and testing these tools with different objectives, obviously. As in academia, they focus about the experimental part of the development. They care about being open source, being able to edit the procedure of the photogrammetry and so on. While the industry focuses on the accuracy, speed, automation, integration with different systems, they care about selling the product. So both of them are creating these tools, they're developing these tools, ending with a huge pool of softwares. So the natural follow-up would be starting to compare those softwares. As if you looked at the current LR, many attempts have been done in the past and recently trying to compare the softwares to each other. The result would usually go as picking a topic or a field, uh, getting the softwares, getting some data sets, and trying testing the data and evaluating the end model. They care about the quantitative outcomes, if I can say that. They care about the accuracy of the model. They care about the speed of the procedure. And a common limitation is they usually ignore the qualitative aspects of the tools. Why do we pick the tools to start with? How do we choose which tools to test? And this is very important actually, because it is the starting point of each research. You start by picking the tool, but it is unfortunately not documented. So here where we start formulating our objectives. We the objectives of the research was to create a list of the most used photogrammetry tool by both academia and the research. We want to identify the different tools, how they fill the gaps in each field, and this we want to visualize the state of these tools. Thirdly, we want to provide insights on how to pick and choose the tools based on your use case or based on your requirements. And lastly, we will compare across the pricing models, the affordability, the requirement of these tools. So starting about the methodology we followed. We divided it into three main parts. Firstly, the tool identification. We care about the tools used by the academia and the industry. So for the academic tools, we looked into tools that are mentioned in the paper from 2020 onwards. We don't care about tools that being used in the past, like in the 19s, that were developed and then stopped improving. So we're looking at newer tools that are mentioned in the academia, and we give more priority to more established publishers. And then looking at the industrial part of the tools, how do we validate them? We basically analyze their market partnerships, their past and ongoing projects, as the companies pride themselves in discussing their partners. So we analyzed their projects, their effects on the real world to get an understanding of the tool and its usage in the market. And the methodology resulted in 37 photogrammetry tools. We identified 37 in order to continue uh, comparing them, both open source and commercial. Secondly, we started formulating our comparison criteria. We looked onto things that are naturally you look for whenever you try to pick a tool. There were seven: the application area, the mode of the operation, the supported operating system, the input data type, the integration capabilities, and the cloud support. And lastly, whether it is an open source or commercial. We'll go into them in details later on. Lastly, the data collection. How do we collect the data and the information about the softwares? There were two main sources for us: the official website and the product manual of the tool itself, and then the GitHub, whether it is in open source. So the requirements files and so on, the community feedback. We depended on those two main sources in order to collect information about the tools that we're comparing. So let's talk about our results. I'll go in a way that will explain how this paper is intended to be used. Firstly, the application and the mode of operation of the tools. The mode of the operation is defined as the capability of the software to deal with certain inputs. So it identifies three main operation modes: the closed range, the aerial, and the satellite. The close range, or we call it close range photogrammetry, is the capability of the software to deal with ground level input taken by cameras or videos from a ground level. And the aerial mode of operation, it is as intended, the capability of the software to deal with the images taken by UAVs, drones, and so on. And lastly, the satellite mode describes the capability of the software to handle satellite files, satellite images, and so on. And as we can see, majority of today's software can handle aerial and close range together, mode of operation together. Moving forward with the area of application, we identify 6 main area of applications, and we order the tools depending on their focus, their intended usage. I'll describe them briefly. The 3D reconstruction and modeling group is the most general one, where the tools is capable of dealing with 2D images and creating 3D models without any specific target or specific field. The GIS and surveying mapping applications that is the tools that focus, as the name intend, the GIS and mapping application. They focus on getting GIS informations and so on. The drone mapping and imagery tools are designed to capture and deal with the drones pictures. And most of them are integrated with a complete environment that deal with drone paths and so on. The fourth group is the infrastructure and industrial projects that are intended for infrastructure planning, projects, and construction management. Fifth is the architecture, archaeological, and heritage documentation. The group focuses on the architectural structures, the heritage conservation, and so on. And lastly, which is very unique, the crime scene investigation and security. Tools that are intended for crime scene measurement, biometric analysis, and so on. And when we plot their usage, plot the tools that we have across the groups as the mode of operation, aligning with the mode of operation and where the tools are being used today, we can clearly see that majority of the photogrammetry software are being used for drone mapping and GIS, and in general 3D modeling and reconstruction. Moving forward with the technical requirements of the photogrammetry tool. After you in a project, when you get the mode of the operation, the application you want, you'll start looking at the technical requirement of those tools. Starting with the supported operating systems, you want to know where do you want to run these tools and which machines. And we can clearly say that all of the tools run on Windows. Almost all of them run on Windows, and majority of them run exclusively on Windows. So it is a need whenever you want to run a photogrammetry tool, you should have a Windows operating system. Majority of them are built and used on Windows operating systems. Secondly, we look at the cloud support, whether the provider of the tool would provide the option of cloud processing, because the hardware requirements of some tools are huge. It is almost an even split. 43% of them offer cloud support, and they're moving towards offering cloud processing for the softwares they provide. Lastly, the integration capabilities. Integration capability is defined as the ability to be used, the tool to be used as a pipeline, API, or any sort of integration within a framework. But as we expect, all of the open source tools have these capabilities, and also majority of the commercial tools. This is a crucial feature for the photogrammetry softwares. You don't need to run them independently. You can integrate them into your workflow. And then we looked at the input data type of those tools. As we can see, it's clearly that majority of the tools until date only deal with images. They 48% of the tools deal with pure images. They take images as input, and there are many different combinations of inputs you can use for these tools. Growing trend is the combination of laser and images. This is the second most used input type, as it produces more accurate 3D model and reduces the cost and the time required. So it is becoming more of a trend. More tools are combining the laser scan data with the images in order to extract the measurements from the images and so on. Lastly, we did a comprehensive analysis. So we created two tables. Everything I mentioned is detailed and documented. So the first table is the open source photogrammetry tool, where the tool is mentioned and all of the attributes that you want. And we discussed area are categorized and mentioned. The area of the application, the mode of the operation, the supported OS, the input data type, and the integration and cloud support. And we did the same for the commercial tools. So whether you're going for open source or commercial, you'd find all the information you need in order to pick and assist in picking the tool you want. To conclude everything, the previous study focused on the quantitative comparison of the tools, while we focus on the qualitative. So we intend to act as the starting point for any research or any ongoing project, where we'd help the users to get us an idea about the available softwares and help them and assist them in picking the right software for their use. And for future work, it is only a starting point. So we will help future will help researchers in test more accurately testing the tools that will fit their needs. That was it for me. Thank you very much for listening, and I'm open to any questions.
Yes, sir. Thank you for the presentation. Any questions, ma'am?
Can I make some questions?
Hello, Mr. Omar Hamid, really great presentation. I have a question. Like I have been working with photogrammetry a little bit, some upcoming project of mine. So,
Mhm.
as far as I learn and search many papers, like and you explain all the tools that are available for photogrammetry. By photogrammetry, we take multiple images of a single object and get a 3D model. Like what
Yes,
if I want to get a room? Like if I get like for example a panorama images or a 360 images of a area of a space, can I get the 3D model of that room or area? Is there any tools available like that?
you want to create a 3D model of a room itself with
Yeah,
pure images.
yeah.
Well, if you, it will depend on the type of images you insert. So as long as you capture all the room from all the angles and you increase the interception between images, almost any tool will be able to create a 3D model of this. But you have to
Like
get the right. Yes.
okay, for images, I want to use like 3D, like a 360-degree image, that
Mhm.
images, that only that a single image. Like for like, I wanted to create a system that when a user get user perspective, we can give the user to take multiple images, right? So like if a user using their phone camera take the 360 image or panorama image of their whole room, can I from
Mhm.
that generate a 3D area of that place?
I didn't find any tool specifically using those type of images, but I think there's some type of pre-processing you can do in order to split the 360 images into multiple images. This might work, but as far as I know, there's no software dedicated to using the 360 images and building models.
Yeah, fine. If the participants have any questions or something, they can just contact them directly through the chat box as we have parallel presentations. So we have a timeline set for it. Thank you so much. Yes, ma'am. Any questions?
Yes, can you hear me?
Yes,
Yes.
ma'am.
Yes, okay. Good morning. Thank you so much for your presentation, Omar. Very quickly, you mentioned that some of the tools are open access tools. So I just wanted to know if it was considered during the research or for future work, some of the disadvantage of this open access technology for like surveillance motives or other not so positive utilization of the technology, if that's something to be considered, even if you mention like satellite imagery and all of that very
Yes.
complex technology. If you can just talk a little bit about that, for I know we have some time restricts, so I'll
Sure.
yeah, go ahead.
I'll briefly go on this. Well, it is open source, so the source code is available, but you have the option to run all the tools locally. So although It is open source. You don't need to share your data with anyone. It will stay locally. There's nothing, no issue in privacy or any unethical use of these tools. You
Okay.
can run it locally. Totally.
Okay. Okay. Thank you so much.
Moving on further, we have our next presenter with us who will be presenting the paper on AI-powered exploration of butterfly plant interaction for industrial farming. Yes, Fahim Afridi. Yes, sir. You can start sharing your screen now.
Okay, hello. Give me a
Yes.
minute.
Yes.
Is my screen presented?
Sir, not yet, sir. Yeah, it's visible now. And you're
Okay.
audible as well. You can start.
Okay. So hello, I'm Fahim Afridi. So I'll be the presenting, and my co-authors are Monima Haq and Abdullah Al Hasib. So our project is the AI-powered exploration of butterfly plants interaction in industrial farming. So the main focus of our project is how we can aid the farming industry by using AI in it. So what it does actually, we want to revolutionize the insect farming with the machine learning approaches. We have many innovation approaches and we have many biodiversity tools. But the one key that we are focused that how can you scale it? In our farming sector, when we did our preliminary researches, we see that there is a very gap and lack of knowledge in the farmers. Like if they have an area where there are many natural predators or natural insect, they sometimes pesticide or kill them. They don't know how to utilize them and how can include them in their farming and to get a better yield. That's where we came in. We introduce an AI system by which using their phones or any devices they can take images of the natural predators or butterflies or anything available to them, and using that they can get the information that what plants they are good for pollination, what then other help they can get. So for the initial research in our paper, we first worked with butterflies. So in many people know that the bees are the main pollinators of flowers for flower farming industry, but butterflies plays also a crucial roles in this industry as well. Like butterfly do also pollination, and finding their preference is a area that is less researched on, that what plants what butterfly prefers as a plants and what flower the pollinators are that. That's the main goal of our researchers. So we may use machine learning to make it optimize it, and you can scale it and improve the growth of butterflies as well. Like butterflies, there are multiple millions of species of butterflies, and each and every individual species have different flower preferences as well. And many people, when it comes to farming, if they do farming of wrong plants, the butterflies present in those specific areas may get lack of food, and they may get endangered as well. So the main goal is of that. So what we use many advanced technique. We use neural network system for a classification model that can classify the butterflies properly. That's the main part of the AI where machine learning comes in play. We have trained a model that can help to identify, classify properly the butterflies is any in the species level. We want to go in more deep also. That is the future plan of our. But initially, our current research is like if you get the wings color and all the other patterns present in the butterfly images, from that we can say which species they are. We have worked with 13 species in our paper, and from that the user can the so we are also collect the data, it provide a data driven solution as well. So let's talk about the methodologies and what we have used. First, we have to create the data collection that mainly work in two stages. First, we take the images of butterflies, multiple sources for each and every species. We have 11 species, and for each and every species, we have to get the data of those butterflies in different orientation or different resolution of images. So multiple vast users can use it at the same time. And next, the hardest part of our data collection was to link those butterflies with the flowers. where they pollinate them. There are very few, I would say, very few websites or very few researchers on that. We intensely did some online researches, talked to various farmers, and we found this few website mentioned here where we get the images of the Excel files that we how many times a flower, a butterfly of specific species interact with that flower in the certain area. And after getting the images, we categorize them manually, label them. At the same time, we complete the color conversation and also resizes and the augmentation for better yield in our machine learning model. And in the data collection, the another problem we face, that is like, if we get the information of the flower interaction of the butterflies, it hard to get the images of the specific species, the vast majority. So that is the permutation combination that we have to did a lot to match the images and also the information of the barrier. That's one of the barrier we have overcome. So next, we did some annotation, marking of the images to get the proper images of the butterflies. So at the same time, so we did some preposition, making the standard colored and everything in a standard size, so it can work in our ML model as well. So we use multiple models. So unfortunately, we had a limited amount of data. The problem we faced, that is the permutation combination. So we couldn't collect a major amount of data, like millions or thousands of data. We only worked with 11 species, but we tried different model. So some model overfit, but our best model was exception. It almost given a accurate validation accuracy of 87.21%. But when it we go went to field testing with this, but it almost like we never found a wrong information predicted by that uh, model when we used the pilot user testing. So that time it worked very well. So next, this is the how the interface work. When a user gives an images of a butterfly, we tell now the name of the butterfly, the scientific name as well, and also the normal local name as well. At the same time, we tell that how many, what is the percentage if you plant this type of trees and this type of flower, how many, what are the chances of this butterfly interacting with this certain amount of that certain the specific flower. So that's how a person can give which flower should they produce if their area of their environment have that type of butterflies in their habitat. If they did farming of that specific flower, they give more better yield and better chance of pollination without using any artificial method, or the system will be full natural. That's one of the main goal. And the next procedure, we have to do the vice versa as well. Like if they have a flower, we would also suggest that which butterfly should they have. We are working on that as well. So it's like a two-way procedure as well. So some people want to do flower farming, or some people want to do butterfly farming. Both of the people can benefit from our system. So we promoted biodiversity and AI tools and implementation of the biodiversity in conservation strategies. This help to scale the and sustain the environment, the ecosystem, and if the food and the demand and supply is fulfilled in a particular area for every species of plants, the growth or the life expectancy of the animals or the flower, that will be better. And for the farmers end, they will get benefited, they will get better yield, and also from the animal end, they will be less endangered. Like it's we want to create a nature and also animal friendly environment farming system, because nowadays in this current world, especially in the third world countries as well, chemical, pesticide, and artificial method to grow flowers or grow crops has seen a vast spikes. And due to those reasons, many animals have gone endangered at the same time. But if we look in thousands of years back or history time, people knew, they went to the animal husbandry, they knew how to use animals to help them with their cultivation and agriculture. That is we want to give this a digital aspect so people can get a hands on it. So this is the reference. We use some of the research paper. This is the website. We try to get an of the interaction of the pollination images. This website contains the for bees and butterflies as well, but I feel more research is needed for this path as well. And thank you. Feel free to ask me any question, and thank you for your patience.
Thank you, sir. Any questions, ma'am? Ruchi, ma'am, Katerina, ma'am, any questions?
Yes, can I ask a question, please?
Yes,
Yes,
please.
please.
Yes, thank you so much for your presentation. It's a lovely research that you're conducting and very important considering the environment and everything. I wanted to know if you are working like in a practical way with some farming business, some if you are doing like this experience with some partnership in the ground, and what are and to know a little bit more about your future research plans, the
So,
continuity of the project.
okay, so professionally, I am a student. I completed my
Mm,
undergrad. I'm currently pursuing a master's and also looking for PhD in uh,
okay.
the US and some other countries.
Yeah.
No luck on that. So, but at the same time, but professionally, I am a lead AI engineer. So
Okay.
my idea is I want to bring research, environment, and also industry together because
Okay.
I have seen when I'm in developed into the industry, people doesn't want to do anything unless they get financial benefit from that. But
Yeah.
my yeah, that's the true. That's the truth of the
Yeah.
word. So if I want the major players of this world are industrial people, and they have the money to help the research of some people or help the animals or environment as well. So I want to show them benefit how animals preserving them can benefit them as well.
Mhm.
That's one of my mentality. So I am still working on that project as well, and I am trying to collect data, but I am a solo person, so I have some
Yeah.
lack of resources as well. And in my main job as an lead AI engineer, currently I am working with cattle. So
Okay.
in my country, there is no insurance for animals. So I'm
Okay.
working with a startup currently as their engineer. So we provide, I'm currently creating the face net, that Apple and everything for detection. I'm building that for animal muzzle. So
Okay.
we can identify them. That is the proposition I'm going to the banks of Bangladesh so they can give insurance to those animals.
Okay.
Also, now future project will be like from animal scars or their wounds. I can predict which malaria or which disease they have, so they can get immediate treatment as well. But I have many plans. I would love to discuss with you further.
Yeah.
Uh,
Yeah, yeah, I can leave my email here on the chat, okay, and we can, if later,
yeah,
discuss.
yeah,
a little bit.
yeah, yeah,
Thank you
sure.
so much,
Yeah, I'll mail you. Thank
and wish you all the best.
you.
Thank
Thank
you
you
so
so
much.
much. Thank you.
Thank you. Thank you, ma'am. Thank you, sir. Thank you, sir, for the presentation.
Okay. Let me stop sharing my screen.
Moving on further. Just a minute. We have our next presenter with us who will be presenting a paper on an exploration of the application of digital twins for healthcare. Yes, ma'am.
Um, I'm Mapula. I'll be the presenter of the paper, An Exploration of the Application of Digital Twins for Healthcare. I was the author, and Fumani Abuseni was my supervisor for my honors research. I will be highlighting the following key sections from the paper: introduction, methodology, results, key findings, and concluding remarks. The healthcare sector has been reluctant to adopt digital technologies overall, but however, the COVID-19 pandemic pushed the healthcare sector to adopt digital twin technologies and other digital technologies. The pandemic presented the healthcare sector with significant challenges, such as there was increased demand for healthcare services, and also there was a need to manage patients remotely. So therefore, digital twin technology was one of those digital tools that were able to aid in addressing those challenges. Digital twin can be seen as a virtual copy or digital duplication of a human or human organs. Digital twin is changing how medical care is provided in such a manner if a patient needs a drug treatment, a digital model of the patient will be built, and the drug will be tested on the patient before the drug is given out to the patient. And therefore, the digital model, we can, using the results from the digital model, we can see if the drug treatment is safe for the patient and how will the patient react. So therefore, it's changing how medical care is given. Digital twin also supports forecasting of disease progression. In terms of oncology, digital twin model can be used to study cancer and the different stages of cancer and how cancer is progressing. And digital twin can be used in different medical fields. And digital twin can cater to the increasing medical knowledge and data that is generated through digital twin models and other models in the healthcare and patients. While humans cannot do that, humans are limited to natural circumstances and natural limitations, such as humans are tired, they work in shifts, so they cannot just always keep on retaining the increasing knowledge compared to digital twin models. For our research, we used the systematic literature review of published research papers using the PRISMA guideline. The main research question that was addressed in this study is how is digital twin technology being applied in the healthcare sector? We used the following databases to retrieve papers to find answers on how digital twin technology is being applied in the healthcare. We selected these databases based on their reputation for publishing high quality studies. The following search phrases and Boolean operators were used and adjusted to fit each database. And we focused on papers published between 2019 and April 2024. The reason that we focused on papers between 2019 and 2024 is because the pandemic pushed more papers to be published about digital twins. So that's why we focused on papers between 2019 and April 2024. For our research selection process, we were able to use the search phrases and Boolean operators from the youth, also adjusting them in the databases. And we retrieved 6,714 articles. And 46 of those articles were duplicates and we removed them, which resulted in 6,680 articles. And we screened each article based on our exclusion criteria, ensuring that we don't include papers that were published before 2019 and ensuring they were in the healthcare sector. So that resulted in 6,556 papers being excluded. And then the remaining papers were 112, and these papers were assessed, the full text was assessed to see if they be able to assist in answering our research question, and which resulted only 34 papers to be included in our synthesis, and the rest were excluded, which were 78 papers. Quantitative analysis was done on our papers to see which papers come from which database. The first figure on the left shows that 3 papers were from Science Direct, 5 from PubMed, 12 from Scopus, and IEEE were 14 papers. And IEEE shows that it was beneficial to our study because most papers come from the database. And on our right, it shows the second figure, the number of articles per publication year, which shows 2019 there were only 2 papers, and 2020 were 5, 2021 were 3, and 2022 and 2024 share the same number. It was 7 articles, and 2023 it was 10. And as you can see, from 2022 to 2024, there was significant growth. And note that in 2024, we only included 4 months. So that shows there was increased research in terms of digital twin technologies. And then we did a qualitative analysis on our different papers that were included. And we discovered there are 5 themes. The first theme is technologies that are integrated with digital twin. These are the technologies that aid in developing digital twin models. And our second theme is application areas of digital twin. This is using digital twin to come up with new methods in different areas so they can be able to improve on the medical care that is given. Our third theme is medical specialty, which focuses on the different medical fields on how digital twin is used. And the fourth theme is digital twin benefits. This focuses on benefits that are associated with employing digital twin in the healthcare sector. And our last theme is challenges of digital twin. These are challenges that are associated with employing digital twin that the healthcare sector have to look at. And the two themes that we have discovered that often interplay with each other is medical specialty and application area, such as in cardiology, a medical field that would use real-time monitoring to monitor patients' health and also to detect cardiovascular diseases. And physiotherapy, real monitoring would be used to monitor and assess the patient's physical health. Are they eating right? Do they need assistance? Those kind of things. In neurology, patient treatment and planning and simulation would be such as before before they do a procedure on a patient, it's tested out on the digital model. So that's how digital twin medical specialty and application area themes interplay with each other. Integrating digital twin with other technologies allows for the creation of virtual patients. We are talking about how other technologies that are integrated with digital twin play a significant role in the development, such as artificial intelligence and machine learning, help in facilitating the personalization of treatment and also make predictions of clinical outcomes that are tested on the models, such as blockchain would be used to secure data. Big data technology would be used in collection of data. So that's how each technology would play a significant role. Digital twin enables simulation of precise prediction and diagnosis, such as in oncology. They leverage digital twin to simulate different cancer scenarios, which enables precise diagnosis and treatment planning without actually exposing real patients to the risk. Digital twin enables real-time monitoring, such in family medicine. Digital twins are used to create real-time monitoring system to monitor patients if they need assistance immediately. How are they doing? Digital twin also supports medical professions in making decisions, clinical decisions, such as that digital twin would provide predictive models and also show medical professions what is the outcome of the treatment that is supposed to be given to the patient. And also medical professions can take advantage of digital twin to enhance their knowledge and skills because digital twin provides a simulated learning and in a safe and regulated environment. Digital twin also can be used by organizations to optimize their resources, such as an example that is written in the paper is that in the radiology department, digital twin was used to streamline operations and which resulted improvements in the radiology department where CT and MRI scan times were reduced for patients and patients waiting times were reduced because they streamlined the operation and digital twin was able to say improve on this is how much MRI time would take, so how long patients would wait. So and also another thing, high quality data is crucial to create accurate models. If we don't have accurate models of patients, it will result in inaccurate predictions or inaccurate clinical outcomes, which would result risk in patients. So these are some of the challenges we have to address, such as ensuring data is of high quality. And in conclusion, digital twin is transforming how healthcare is given. Now treatment can be tailored to fit a patient individually. Medical professions can take advantage of digital twin to enhance their skills by practicing procedures beforehand using digital models. Organizations can use digital twin to optimize their resources. And while it uses digital twin to optimize their resources, organization costs can be reduced. So therefore, that's how digital twin is transforming the healthcare sector. But overall, challenges must be addressed to reap the full to reap the full benefits produced by digital twin. And challenges are ensuring data is secure, data is complete, data is accurate. Those kind of challenges must be addressed. And to realize the full potential of digital twin calls for more collaboration between researchers, medical professions, and medical product developers. And thank you so much.
Thank you. Any questions, ma'am?
Thank you so much for your presentation. It's a very delicate topic as you have presented. I would just like to know if you, in your research, you found about some areas or some countries that are already using this type of technology, and if so, what are those areas that
The
you for?
only company that we have been is Hanethers that are in Germany that have used digital twin, but they haven't built out digital models of patients. And also in America, the food discovery drug development programs have been used to test out drugs on the virtual models of just to see how the model would react to drugs, but it's more or less not personalized yet. It's just data that is taken from just samples of patients. So USA and Netherlands and Germany would be the ones that already.
Okay, and in a more like company-based technology is being used more like pharmaceutical companies, right? Not healthcare systems.
Yes,
Or
not health. Yes, only pharmacies have already started to use it out in drug development, but organizations, the research is just, the purpose of the research is to spread out the word that there's a new technology that can help in different medical sectors and how they can utilize it. Okay. Because it's not a lot of people know about the technology, and some countries don't know. Yeah.
So thank you so much. It's a very interesting topic, and I wish you all the best luck with continuing your research.
We have our next presenter with us who will be presenting a paper on deep learning based pneumonia identification using 3D gradient weighted class activation mapping visualization.
Okay, everyone see my screen, right?
Yes, yes.
Okay, thank you. Good morning, everyone. My name is Gornpom Pikunka from Department of Computer Science, Faculty of Science, Chiang Mai University, Thailand. And today I will present you about deep learning-based pneumonia identification using 3D gradient weighted card activation mapping visualization. Okay. First, let's talk about agenda. Today, I will talk about first introduction, methodology and results, discussion, and finally conclusion. Okay, let's go to the first part, introduction. I think everyone know about pneumonia already, right? Pneumonia is like a serious lung infection that affects millions of people around the world, particularly young children, the elder, and those with weakened immune system. I think if we can develop a system that can understand pneumonia and use the AI technique, we can develop more effectively scalable and explainable diagnostic tool that help people a lot around the world. And maybe we can reduce the mortality rate of this disease. So in our contribution, we plan to use the 3D gradient weighted card activation mapping on platform to provide clear for pneumonia detection. And this system, we plan to scalability. We can use in the low resort environment in another clinic or hospital around the world. About the objective of research, we will investigate the impact of data augmentation on model performance, evaluate the performance of variant CNN architecture like RedNet 50, effectiveness, or MobileNet for pneumonia detection using shed X-ray. Okay, about benefits of this research, I think it will can support for There is in decision making, and maybe it can improve Romanian diagnostic accuracy. And the last one, I think, is help medical staff to route over patient who, in some cases, require 24-hour monitoring, which contribute to stain. Okay, and about the scope of the study, we will utilize shared X-ray image for pneumonia detection. So we will focus on extracting key features from lung image using deep learning model, and we will try to implement CNN or cohesion neural network for pneumonia classification. Moreover, we will use 3D CAD CAM to highlight critical lung lesions that are influencing model decision, and we aim to support early detection and decision making in hospitals. Okay, about methodology and results. In my research, we will divide into 4 processes. First one is pre-processing, next processing, next processing, and finally iteration of the process. In phase 1, we use data sets from the NBC dataset that have 8,000 images categorized into 2 cassettes. First is pneumonia and another is non-pneumonia. And after that, we will try to normalize the image so that reduce bias, change the type of the image to be the same, change the DPI to be the same, and apply data augmentation like a basic geometry transform, rotation, translation, sharing, shipping, something like that to increase our data set. So the total number of images will be 10,000 for each class. And this is, let me show you the UNBC dataset for you guys. You can see in this dataset, it have around 8,000 images with the pneumonia and non-pneumonia. You can see in this picture. And this is the picture of non-pneumonia. You can see in this picture. And this is the pneumonia image. Okay. In fact, too, we will utilize convolutional neural network or CNN to separate pneumonia detection from the shared X-ray. And in the future, we will try to apply TD deep learning for improve the performance of the system. So the data will be processing using deep learning method. Or maybe in the future, maybe you try a hybrid model to combining approach for heuristic detection. We use 70% of image for training, 15% for validation, and 15% for testing. We're processing on CPU Intel i7 with RAM DDR4 32 gigabyte. And we training setting including specific optimizer choice, both baseline and epoch to optimize performance. For the training phase, we choose Adam with a starting landing rate, with 0.001 and a baseline of 64, and training for over 100 epoch with the every stop technique for overfitting reduction. And we use the pre-trained model like RNet 50 because it can robust for classification. And another one is effectiveness. It can help us a lot because it can balance depth, width, and resolution for high performance. Another one is mobileness. I think it's very optimized for the efficiency when you have a raw resource. Yeah, something like that. And why we need explainable AI? I think explainable AI can help the medical staff to classify why deep learning got you the result, something like that. It's like a black box for a long time. But if we can use the explainable AI, I think patient will understand more than before. And because it can transparency, trust, and insight. That's why we use the explainable AI to tell the results of the process. And this is feature of we use GradCam or gradient weather card attribution mapping to visualization highlight important image region. You can see in this picture, it's helped us a lot to interpret how and why the model classify the disease. So you can see in this picture. And in the future plan, we will try to use advanced explanatory like a local interpretable model explanation or LAMS or sharply additive explanation. And interactive, we test and integrate our system. Let me show you the results of this research. You can see in this picture, the first one is pulmonary card, right? It's confidence level is up to 99%, while the right picture is another pulmonary class. Its confidence level is 97%. You can see in this picture, and you can see the work of the GAD-CAP. And another example is normal cast. You can see on the red picture is normal cast, and the right picture is the same. And another example, the first one is normal cast, right? And the last one is the pulmonary cast. Okay, I will move on to the next part. In phase 2 evaluation process, I think every research need to be evaluation process, right? So we will invite a doctor or expert from the Faculty of Medicine and Faculty of Public Health to evaluate the system. And you can see in this table, we show the overall accuracy, but actually we have a lot data using confusion matrix. You can see on the mobile net, we can up to 97.51% accuracy without data augmentation. But in the effective net, we can read up to 97.12 accuracy with data augmentation. While RedNet 50 improved from 89.74% to 93.67% with augmentation. Let's move to the next part about GAD-CAM result. So we can got the result that GAD-CAM can highlight lesion, including key feature that we use for classification. About the challenge of research, I think we study only binary classification, only pulmonary and non-pulmonary, right? But in the future, we will try to expand another type of pulmonary, because in the real world, we have many types of pulmonary, right? Like a bacterial pulmonary or virus pulmonary. And that will be our future work. And we will try to implement like alarms or sharp. That is the advantage explanatory AI, and we will use 3D CNN for help us to improve the performance of our system. And so conclusion, in the input, we use the dataset from the MBC dataset, and we processing using deep learning method and use pre-trained model like RedNet 50, effectiveness or mobile net. And the output, we got the pulmonary cast and non-pulmonary cast. And this is our system workflow you can see in this picture. Okay. Sorry. Okay. Okay. Sorry. And this is our team. And this is our reference. Thank you for your time. If you have any question or suggestion, please feel free to ask me. Thank you. Thank you so much.
Thank you, sir. Yes, ma'am, any questions?
Thank you so much for the presentation. I would just like to know if you have plans or if you are considering this type of technology, if it could be adapted to other diseases, respiratory diseases, and if you have plans to incorporate these technology methods to other disease areas.
Thank you for the question, Professor. Yeah, I plan to explain maybe in the brain thermal, something like that. And now we work on the emotion detection in animal. I think it's we can know the emotion of your pet. It will help human a lot. Yeah, right. Yes,
Yeah,
I
that would
have
be
that.
very cool.
Yeah, I agree. Yeah.
Okay. Yeah,
Thank
thank you
you.
so much. Thank you so much.
Thank you, Professor.
Thank you. Thank you, ma'am. Thank you, sir.
Thank you.
Moving on further, we have our next presenter with us who will be presenting the paper on empowering pathways, the impact of career exploration and self-efficacy on student adaptability through career calling and STARA awareness. Yes, ma'am. Helvira Maharani Tresnadi.
Yes, I
Yes,
am
ma'am.
here.
You can. Yes, yes, I can hear you. You can start sharing your screen, please.
Okay, please wait a minute.
Yeah. Till then, do we have the presenter of the paper title Evaluation of Deep Learning Techniques for Non-Destructive Test? Do we have the presenter of this paper here?
Okay. I'm
Okay,
here.
everyone.
Yes.
All right. Helvira, you can just fix your issue
Okay.
and then you can come back.
Okay, thank you, ma'am.
Yeah. Yes, sir. You can start sharing your screen.
Okay, may I finish? Am I starting?
Yes, yes.
Okay, thank you. So, hello, ladies and gentlemen. Today I present my project in the using AI technique for to test to the non-destruction test for the auto building in the Kaohsiung. It's Kaohsiung City. For 5 years ago, during a year, I study PhD in there. So the data we collect from there, and after that I use deep learning. It get recruits unit and long short-term memory for to to test and experiment for that. And sorry. Okay, you see everything. Okay, and my presentation is the six part from 1 to 6. And right now, I will can how I use the non-destructive test. Was if you know it, non-destructive test NDT is very important for to use building. Because they can broken concrete everything. Maybe use the combine to ribbon hammer. I have an ultrasonic velocity to combine for to take the old building. I do know a beam the building over 30 years. It's very the risk is very high for the building. As you know, Taiwan is tsunami and earthquake every days, every month. So we have to take to make the safety for the holdings and everything. And later review that we are used to find the research is similar in other study for to relate to non-destruction tests as you know on the screen. And my objectives are use the AI model to predict the compression strength correct in the Pamir department, asset efficient after AHA and UPV test to evaluate concrete strength, compare different activation function and the impact on the accuracy, promote improve concrete strength and result to deep learning. Okay. And methodology we use 97 sample for the experiment. And after that, the data I use 80% data for training and 20% for testing. After that, before to to use the deep learning implementation, I use the approach data analysis to assess variable, reliable, and relationship between three variable for us, and use deep learning to use the training user reward Hammond and Utah values to predict person strength. And after that, I use find the activation function AFs to test for accuracy improvement. You know, this is the diagram of the LSTM, long short-term memory model. And the component for model is the side input use the 14 nodes, later hidden 10 and get output on one node. I use other software optimize collect for the data set method MSE to choose the performance function. Epoch time is 500 and 20 batch. In addition, the activation function for the layer include both in order to find the better for experiment. And they are used. Model is this one diagrams for that, and the best component is similar STM model. And after that, the use that it find function activation is the Tanlu, sigmoid, relu, and liquilu. 10 lu is combined to 10 and 10 mode 10 activation and relu activation. After that, you use for to chart of the model, the curve from the derivation curve and sample curve. After that, the data. After that, we use a normalization for to increase the accuracy for during the training by the model. And performance figure of the parameter that I use for the parameter MBP, R, MAE, and R square. That is chart for the research everyone. After results, we are to use EDA analysis, as you know. This the descriptive statistic for the three variable for the input data. You have to know we are used for the parameter mean, standard deviation, minimum and maximum. Okay, we see that the mean and standard deviation very close for to statistic. Therefore, the sample is suitable for the research. And after that, we use Pearson correlation for input data and key insight. AHAT and UPV show very correlation with compressed strength. Pearson correlation analyzed the ribbon hammer shows a moderate positive correlate and 0.4, and UPV show negative correlation minus 0.5. And after that, we use deep learning for the training, and to diagram for the training loss and vanilla loss. After using five activation function for two model, all the training and epoch time 100 will drop, and after that overfeed and it 500. Therefore, the condenser of the five activation for two model is very good. And after that, And after that, we are to show. After that, we with the indicator parameter. You know the table. You know that R squares, R square and FPB is very high, so suitable for the network. After then, you know it's a bit to training and testing to comparison with simulation and actual. And you know the R square in the black line and blue dots. So you know the last everything to over 5 and 207. I squared it as suitable for to research. And deep learning like you know that I rule of perform the SE integrity, bad performance operation to a kilo and 10 loop. Sigma function result in lowest forecasting accuracy. And conclusions, and after research, we are shown to some the conclusion defending after the deep learning model effect breed correction strength. We argue the performance LSTM, so better correction. At back activation function, the hybrid group, Likilu and 10 loop back from Relu and 10 modern accuracy and small low accuracy. Complete activation improve breed accuracy more than the individual IFs. Implement filter work deep learning use the health monitoring and AI structure filtration over open data more accurate and reduce computer complex training and redo model. Thank you for listening. Any question?
Thank you, sir. Yes, ma'am. Any questions?
Thank you so much. I'm just curious if you have some clues for future directions of reducing these very complex computational programs and in tests. If you have directions for that or clues how to achieve that.
Okay, this R2 model is very popular for deep learning. And so generally we choose a sample and you test the sample to high reliability for to training and testing. And except the non-deduction contract, and you can to apply for to test it. To test it the beam or steel beam for to high building, and you can to see basement for to build for the building.
Okay. Okay, thank you so much.
Okay, thank you.
Thank you, sir. Thank you, ma'am. Yes, Helvira, are you ready now?
Yes, I'm ready.
Yeah.
Okay. Good morning, distinguished guests, fellow researcher, and esteemed committee members. It is an honor to be here today at the ICICT 2025 conference in London to present our research. Introducing me, I'm Helvira Maharani Tresnadi as the first author, and they are my colleagues as the other author, Rani Oges Pebina, Mata Chandra Lagita, and the last Nurul Sukmalestari, and we are representing by Binus University. The title of our paper is Empowering Pathways, the Impact of Career Exploration and Self-Efficacy on Student Adaptability Through Career Calling and STARA Awareness with paper ID number 744. investigate this critical role of career exploration and self-efficacy in shaping student adaptability in the evolving job market. We especially examine how career calling and STARA influence this relationship. We hope our research can provide valuable insight to the field, and we look forward to discussing with you all. Thank you for your time and attention. Starting from the background, career adaptability is crucial for students to navigate the ever-changing dynamic of the job market, aligning with the Sustainable Development Goals number 8, focus on decent work and economic growth. In Indonesia, the challenge of 8.43 million unemployed in August 2022, including 673,490 university graduate, the mismatch between job seeker qualification and industry need is also a problem that needs to be addressed. Therefore, student needs to develop adaptive skill to be ready to enter the workforce. University play an important role in equipping students with this skill, integrating academic knowledge and adaptive abilities to enhance career prospects. Career calling, career exploration, careers, and self-efficacy are key components in building career adaptability, enabling individual to persevere and succeed in dynamic work environment. Furthermore, understanding and efficiently utilizing technology as well as awareness of the potential uncertainties in creates can enhance career adaptability, especially in industry heavily influenced by technological advancement. This study aims to find out the extent to which university students in Jakarta seek information about their dream career and how confident they are pursuing them. In addition, this study also wants to see whether this confidence make them really driven to get the job they want, thus providing inner the satisfaction and positive energy in their life. In addition, this research will also examine how technological development affect their dream career and play a role in their ability to adapt to the world of work. So in this slide, I will explain about our literature review. The first, career exploration. Career exploration is help students navigate the career landscape by identifying their interests, strength, and aspiration, improving adaptability and decision making. Second, self-efficacy. Self-efficacy or confidence in one's ability to succeed, enhance career choice, adaptability, and professional identity, contributing to long-term success. Third, career calling. Career calling signify a strong connection between work and personal identity in fostering purpose, motivation, and psychological well-being. The next one, STARA. STARA is the abbreviation of Smart Technology, Artificial Intelligence, Robotic, and Algorithm. Represent technological advancement that are reshaping industry, highlighting the important digital skill and adaptability. And the last one is career adaptability. Career adaptability is the readiness of the handle career transition and unexpected challenge, equipping individual with the resilience to thrive in the dynamic work of environment. And this is our framework. Considering the initial findings and the established framework, the following hypotheses are proposed as the basis for further testing. And therefore, the following hypothesis can be proposed. We have 8 hypotheses. This is our hypothesis testing result. Accepted as their t-value exceed 1.96 and p-value are below 0.05. Notably, hypothesis 6 showed that STAR awareness weakened. The impact of career calling on the career adaptability of the EVAC remains significant. This weakening can be attributed to the fact that students becoming more aware of the changing career landscape. My experience increase or uncertainty or a shift in priority regarding their curriculum. Such awareness can cause students to question and reassess their career goals. potentially leading to decreased confidence or adaptability. Despite this weakening, the relationship remains statistically significant, highlighting the importance of supporting students in aligning their curriculum with the evolving demand of the job market. All the other hypotheses are fully supported. This is our methodology. For population, we have students who studying in Jakarta, Indonesia, and for respondent, while the study required 370 samples, it successfully obtained 413 valid responses, providing the stronger data for analysis. For quantitative, this research used quantitative methods through uh, online questionnaire survey. The quantitative method was chosen because it allows objective and systematic measurements so that the result obtained can be tested for validity and reliability. And the data obtained were analyzing using the structural equation modeling (SEM) with the partial least square (PLS) approach, which was measurement through smart PLS software. For measurement, career exploration was adapted from the research of Prativi and Irawati 2020. For self-efficacy was adapted from the study by Zhang et al. 2022. For career calling was modified from the research of Wu et al. 2019. Stara awareness was measured using the instrument developed by Broham and Hart 2018, and the last career adaptability was adapted from the research of Lin Qiang 2023. This is our finding. From the data obtained, 63% of the participants were female and 37% of the participants were male. On average, the majority of participants came from management major. In addition, the participants of this study came from Jakarta, Indonesia. This is our data analysis. To ensure the validity of this research, the data was assessed against predetermined criteria, a loading factor above 0.7 and AVE greater than 0.5, and composite reliability and Krombach APA exceeding 0.7. To optimize the result, indicator failing to meet the loading factor threshold of 0.7 were systemically removed into stage. The first round eliminate M6, Z1, X1.5, and X1.6, while the second round eliminate X2.1 and X2.2. Consequently, the table result reflect the data after this elimination, ensuring that all remaining indicators meet the established validity criteria. And this is our conclusion. For implication, developing effective career programs to enhance student adaptability demands integrated action from educator, institution, government, and industry, ensuring students are ready for the dynamic workplace ability. And for limitation, we have the limitation. A limitation of this study is restricted by geographical scope, as data was collected solely with Jakarta area. For future research, this is recommend to investigate variable within a broader scope at the national or international levels. And for recommendation, educator and educational institution should design programs that integrate career exploration, confidence building, and technological understanding into their curriculum. Thank you for your time and attention. I will be happy to answer any question or suggestion you may have. Thank you.
Thank you, Elvira. Thank you for the presentation. Yes, ma'am. Any questions?
Yes, thank you so much for your presentation. I have one question. You gave some of the characteristics of your sample, and this was conducted with university students, right?
Yes, right.
So maybe for future work, or maybe if you already contemplate that in this work, would be interesting to know if the results will be different or differentiate between degrees of scholar formation, right? So if people with higher education degrees are more susceptible to adapt eventually and to have careers that go in the direction of these new technologies. I don't know if that was something that was contemplated in this work, but maybe that this would be something very interesting in the future to take in consideration when we explore that with also a broader sample in the geographically, and it could maybe help you give more to the discussion and to like comments and feedback for the educational professionals.
Okay, thank you so much for your suggestion. This will help my future research.
Okay, and congratulations for the work. It's very interesting and
Thank
important
you so
in
much.
the contemporary now.
Thank you. Thank you, ma'am. Thank you. So we have come to the end of this session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9th versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer board, and the publication will be live within 6 months. So kindly cooperate with the team of ICICT 2025. I would also like to thank our session chair. Thank you, ma'am. Thank you, Professor Katerina, for chairing this session. It was great to have you here, ma'am. This is a token of appreciation from the team of ICICT and Global Knowledge Research Foundation and their partners. Thank you so much, ma'am.
Thank you so much. Thank you for
you.
having me.
Thank you, ma'am. I also would like to thank Professor Ruchi Sharma for chairing the session. It was also great to have her here. Thank you. Thank you so much, all the session chairs present here. I also request the participants to turn on their cameras for a quick snapshot, please. Thank you, everyone. Thank you so much. It was great to have you all here. Take care. Thank you. Bye-bye.